Assalamualaikum. My name is Affiq Anwar bin Arsad. I am student from Mechanical Engineering Department at UNICEF. So today I will present my final year project, which is Computational Fluid Dynamic Study of Flow Behavior and Pressure in the Exhaust Muffler for cars. Okay, this project was conducted by me with supervision from my supervisor, which is Madam Siti Mama binti Rosman. So let's begin. Okay, first I will go through with the problem statement in this study. Okay, in this study there is three main problems that need to be addressed. Okay, the first one, um, a high blood pressure exists in exhaust muffler. This problem occur in the current design itself, where it create high blood pressure in some part of the muffler. Okay, because of it, it also making a second trouble to follow up, which is a low flow rate of exhaust gas inside the exhaust muffler, where it affecting the whole fluid, or in this case, exhaust gas flow in the exhaust system itself. Okay, because of these two problem, it raises the third problem, which is a burden on the engine, where it need to work more to push back all of the gases away and ensure it will not flow back to the engine. So in the study alone, I want to solve the first two problem, because if those two problem can be catered, the third problem will follow automatically. Okay, now let's talk about the objective. Okay, there are four basic objectives here in this study. Okay, the first one is of course to study the airflow of the exhaust muffler. Since I'm going to do about the airflow itself, so the first step is definitely I need to study about it first. Okay, the second one, I have to analyze the back pressure inside the current exhaust muffler. Since this design is referring to the already in market product, so there is no doubt that this analysis where it will should give me a single consistent result. So after that is done, it is compulsory to modify the existing muffler design in order to increase the airflow, lowering the back pressure to increase its performance. Okay, since this study is focusing on performance alone and not the loudness of the exhaust muffler itself, so the design will focus on how to give it better performance. Okay, to make thorough analysis on the modified design is taking place. Okay, to make my objective ahead, I need to ensure that the back pressure and the flow rate after the modification giving a positive rate compared to the current design one. So in this study, my methodology is divided into two steps, which is designing and simulations and analysis. Okay, so for me to make it happen, I use help from two software, which is the first software is SolidWorks software that is responsible to my CAD designing of the current muffler from its current design until its modification. Okay, the second software I use is ANSYS Fluid, where its job is to run a simulation of the CAD model and make an analysis from it to give me a readable result. So the first method is I draw the CAD model of the current design of the exhaust muffler. And after that, I'm doing simulation analysis on the current design of the exhaust muffler, which is I'm using ANSYS software. Okay, after that is done, I draw the CAD model of modified design of the exhaust muffler. Okay, after that, I'm doing simulation and analysis on the modified design of exhaust muffler using ANSYS software again. After all of the method was done, here is the result I got. Okay. Okay, so for the first result, I get the rate of the mass flow rate between both of the current design and the modified design. Okay, so from the table itself, it is shown that the modified design of exhaust muffler had better mass flow rate since it had higher rate on the outlet compared to the inlet reading itself. Okay, do mind that the net value is come from the subtracting the inlet value with the outlet value, which is modified design is superior because of the outlet flow is higher than inlet flow, which is like a vacuum on the outlet on the modified design compared to the current design that has inlet flow that is still higher than the outlet one. So the second result I got from the simulation is the pressure reading inside the exhaust muffler. Okay, there is a two value here, which is a minimum and maximum. So we focus on the maximum value, which is the maximum value is what causing the back pressure itself in the exhaust muffler. So from the table alone, it can be seen that the modified design on exhaust muffler itself had a lower pressure compared to the current design. This value show that even with the modification, a pressure still exists in the exhaust muffler. However, after this few modification, the value seem to be decreasing, and to me this alone is quite an achievement in order to increase the performance of the engine itself. So this is illusion being generated by the ANSYS software itself about the pressure difference inside of the exhaust muffler. On the other part, I got the result of the velocity of the exhaust gas flow inside the exhaust muffler itself, where it is a bonus result that will strengthening the two results I got before. Okay, from the table, it can be seen that the modified is have a higher maximum velocity, where it proved that the gas flow will increase after the modification. It also does give a hypothesis that a lower back pressure helps with the gas flow velocity to go through the exhaust muffler. So this is the streamline flow of the exhaust gas illustration generated by the answer software. So let's discuss here. Okay, I think it should be discussed that an improvement is an important element in any modification, where in this case is the improvement on the gas mass flow rate, okay, and the back pressure created by it. Okay, another part that it should be highlighted is since modification is a subjective subject and can come up with very diverse possibility, I think it should be mentioned that trial and error is needed to get the objective in modification. Okay, if the first try is a failure, it should be done again and again until the desired result is shown. Okay. Lastly, I think I should agree that CFD software helps in simulation analysis, where it saves the cost compared to making a prototype and run the test inside lab. So what's the conclusion here in this study? Okay, number one is the mass flow rate of the exhaust gas increase. Okay, number two is the back pressure exit inside the exhaust muffler is decreased. Number three is the velocity of the exhaust gas through the exhaust muffler has been increased. So with these three conclusions I got from the process of modification of exhaust muffler design, it can make the engine perform better and reduce the burden on the engine. Okay, so now this is a Q&A session. So any question about it so far?